All right, here's another example from section 5.4. If we look at this one, we see that this one has a log on one side and no log on the other side. So that's a classic example of, log base A of B equals C. How do you solve that? Well, one thing you can do is switch your form, and A to the C power equals B. So that's what I'm going to do here. It's in this form, log base A of B is equal to C, right? Although it looks complicated, it's still in that form. So I can switch it and say this is 2 to the third power equals 3x minus 7 times x minus 4. That's 8 equals 3x squared. And then we got 7x, negative 7x and negative 12x gives us negative 19x. And then positive 28. We switch, when you subtract the 8 on both sides, we get 3x squared minus 19x plus 20 equals 0. All right, here you could just plug it into the quadratic formula. I like to factor. Would rather factor it, or try to factor it. Write it as x squared minus 19x plus 60. And then I'm thinking two numbers that I can multiply together to get 60 that I can add together to get 19. So 60 is 15 times 4. Which would give us 19, so x and x. Negative 15 and negative 4. Yep. So we got to remember to come back in here and compensate for that 3, so we divide by 3. We get x equals, so that'd be x minus 5, so it'd be x equals 5, and x equals 4/3. So you wanna plug them in to make sure it's not, neither one is giving you a negative number. So you can kind of do that quickly and say, all right, 4. All right, so if it's 5, 3 times 5 minus 7 is still positive, and 5 minus 4 is still positive. All right, so I know 5 works out. It's positive. What about 4/3? So that's like 1.333, right? So 3 times 1.33, that's just 4. That's negative. But 1.333 minus 4 is also negative, and a negative times a negative is a positive. So both of these are going to work out. All right. So this one would be one that you can try on your own. This will be a good time to pause the video and try it on your own. All right. So same thing, we can switch it and say this is 3 squared equals x plus 5 times x minus 3. That's 9 equals x squared. 5 and negative 3 means positive 2x minus 15. Subtract 9 on both sides, minus 9. We got x squared plus 2x minus 24. Try to factor this, x and x. 24 and 2, so two numbers you can multiply together to get 24, that when you add them together you get 2. 6 and 4. So it'd be positive 6 and negative 4. So x, that equals 0. So each one of these equals 0. So x equals negative 6 and x equals positive 4. So which one of these, did both of these work out? Let's see. Negative 6 plus 5 is still negative, and negative 6 minus 3 is still negative. and a negative times a negative is a positive, so we're good there. And then 4 plus 5 is positive, and 4 minus 3 is also positive. A positive times a positive gives you a positive. So both of these work out. All right, example number 8. We have multiple logs on one side, but no logs on the other. So this is very similar to example 6 and 7. You can kind of combine those. We needed to make it one log, so we can say log of 3x. Oh, that's going to be multiplied. 3x plus 2 times x minus 1 equals 1. Now, a couple things to know. When there is no log base, it's understood to be a 10. That's called the common log, right? Log of x really equals log base 10 of x. So, common log. So this right here becomes 10 to the first power equals 3x plus 2 times x minus 1. That's 3x squared. That'd be 2x and negative 3x, so that's negative x, and then negative 2, and that's equal to 10. It's quadratic, so we need to get it set equal to 0. So we subtract the 10 on both sides. We got 3x squared minus x minus 12. Then you can factor this, or you can do whatever you want. Complete the square, however you like to do it. Maybe I'll do it completing the square just to show you. So let's do completing the square. How do we do that? Well, we get the x's by themselves. So it really is going to be 3x squared minus x, leave a blank, right, equals 12. And this one would be one that I would think this would probably be the hardest method to do, but we already locked in now, so we're just going to do it. You don't want this 3 here, so you would divide by 3, and you can do that on both sides, or you can just factor it out. So this would be x squared minus 1/3 x, and then equals, this is going to equal 4. Then you're going to take this middle term, negative 1/3 divided by 2, and then square it, so that's negative 1/6 squared, which is going to give you 1/36. So you're going to add 1/36 to this side, and you do the same thing to the other side. All right. So the beauty of completing the square is that every time you do it, it's going to be perfect. When you factor this fraction, weird trinomial, it's going to give you x minus 1/6 squared. You're going to get x minus 1/6 times x minus 1/6 equals 4. I'm going to put this in my calculator real quick. I don't know what that is. 4 plus 1/36 is 145. 145 over 36. And then I'm taking the square root of both sides. So that's x minus 1/6 equals plus or minus. Let's see if that gives me a nice number or if it's something terrible. It's something terrible. Why? So I'm going to just say the square root of 145, and then that's over 6. So your final answer would be x equals 6 plus or minus the square root of 145 over 6. Man, I wouldn't want to leave. I mean, that's the final answer, but I feel like this 145 we could simplify. Yep, this was definitely the worst way. Anyway, would probably have been better than this one, but what are we going to do now? 145 divided by 5 is 29. 5 times 29. I don't think you can. 29 divided by 3. Nope. 29 divided by nothing. 7. Yep. I think that's what it is. That's weird. That means that we couldn't factor it. Could we had factor? Unless I did something wrong. So let's try to factor it. Let's see if I could have factored it. So 3x squared minus x minus 12 becomes x squared minus x minus 36. Two numbers that you can multiply together to get 36 that you can add together to get 1. So 36, I can say divide that by 9 and I get 4. I can say 36 divided by 6 and I get 6. 36 divided by 12 and I get 3. 36 divided by nothing. So you couldn't factor this one. So you would have to have done quadratic formula or completing the square. I just picked the nice one. No. So that would be your final answer. Or you could put it in quadratic formula and get your final answer that way. Yeah. I would say you probably need to check the negative version. So if you put this in your calculator and you say this is 1/6 minus the square root of 145 divided by, or let me say 6, that gives you a negative 1.8. 3 times a negative 1.8 plus a 2 is still negative, which means your negative version won't work. So x equals 1/6 plus the square root of 145 over 6. The negative one is extraneous because when you plug it in, it ain't going to work out for you. That's a nasty one. We're getting there. Yep, number 77. You should try that one on your own. I'm not going to run you through it, though. Although I could. Maybe I should. Yep, sure. Why not? Go ahead and try it on your own first. Look, they got this property coming up. They'll show you a property, but I'm going to use the same way. So look, there's a lot of different ways to do logarithms. I can't show you all of them. I'll just show you the direct routes and hope you understand. All right, we can write this as log base 2 of 2x minus 3 times x plus 1, right? This is all inside the log, equals 1, which means that we can switch it and say that's 2 to the first power equals 2x minus 3 times x plus 1. This right here is 2x squared, then that's minus 3x plus 2x, which gives you minus x, and then minus 3. This is a 2. Then we got 2x squared minus x minus 5 equals 0. All right, this is another one that you can't factor. Yeah, because 10 is 2 and 5, 5 and 1. So you wouldn't be able to factor this one, but you can always plug it into the quadratic formula, which is your answer equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Or you can complete the square. we'll do quadratic formula this time. So negative 1 plus or minus the square root of negative 1 squared minus 4 times 2 times negative 5 all over 2 times 2. So that's 1 plus or minus the square root of, so this is 1 plus 40, so 41. Yeah. All over 4. And that's your answers. You got 2 answers. You gotta see which one is real and which one is extraneous, if any of them, right? Remember, you can't have the log of a negative number. So if I say 1 plus the square root of 41 in my calculator and take that and divide it by 4, I get 1.85. And if I say, so x equals, approximately 1.85, if I plug that in 2 times 1.85 minus 3, that's positive. And then 1.85 plus 1, that's also positive. So I know this one is going to work. As long as I did my math right, this one works. My other one is x is approximately negative 2.7. Just 7. I'll just leave it like that. So 2 times negative 2.7 minus 3 is still a negative number. So I know this one cannot work. All right? Because when I plug it in this first part, or if I say negative 2.7 plus 1, you're still a negative. You can't have a negative log. So this is extraneous. All right. So this one. Couple things to know when you're looking at this one. If you have, if you have log base a of a to the b power, then this thing is automatically equal to b. Right, we talked about this before. Basically, if you switch the form, if you don't know what this is and you say question mark, then it's a to the question mark power is equal to a to the b power. So these two things are equal. Right, so keep that in mind. So also natural log. Natural log is log base e of x. That's the same thing as ln of x. So when you see the natural log of whatever, the natural log of a, that really means log base e of a. Just like common log, except it's not a 10, it's an e, and they write it different. So when you're doing these, you should really think about this. What this means is this is log base e of e to the ln x minus, I'll just do it one level at a time. Like that's the one that I see, minus, I'll just say ln of, well, no. Log base e of x minus 3 equals log base e of 2. Right, now this and this match, so I know this whole thing right here just comes down to be ln of x minus, now since this is also ln of x, I can rewrite it as log base e of x. So it's log base e of x minus log base e of x minus 3 equals log base e of 2. Just bringing all this other stuff down. Well, since they have the same base, I can rewrite it log base e of x is being subtracted, so and then I can say x over x minus 3 is equal to 2. And now I can solve by saying x minus 3. Hey, remember, gotta remember though, because it's in the denominator, x minus 3 cannot be equal to 0, so x cannot be equal to 3. Just in case. All right. Multiply by x minus 3 on both sides, and we got x equals 2x minus 6. And then, you know, we'll call it 6. Come back up here. 6 is equal to x. We want to make sure that that 6 is good. Yeah. I'm going to let you do that one. All right, so here's these rules that we've been applying to solving these. Take a minute and go through them. But my strategies don't always match what the book's doing. So don't get it in your mind that that's the only way. I think this is the last one I'm going to do. And this says, the strength of a habit is a function of the number of times the habit is repeated. If n is the number of repetitions and h is the strength of the habit, then according to a psychologist, h is equal to this, where k is a constant. Solve the equation for k. All right. We want to solve for this variable right here. Get it by itself. How are we going to do that? First, we got to make this 1,000 go away. So we divide by 1,000. H divided by 1,000 is equal to, you know, since that 1,000 is not there, we don't need this 1 in parentheses with the, all right. So then we can subtract 1. So that's h over 1,000 minus 1 is equal to negative e to the negative k n. All right, this is like exponential form, but there's something, remember, if we have it like a to the x power equals, or a to the b power equals c, then I can say log base a of c equals b. So right now, this a to the b power equals c, right? But I got to get that fixed. So I need to get this negative, so I divide both sides by negative 1, divided by negative 1. That becomes negative h over 1,000 plus 1 is equal to e to the negative k. And this one's kind of getting weird on us. But now we're ready to switch forms and say this thing is log base e of negative h over 1,000 plus 1 is equal to negative k n. Divide by negative n, divide by negative n, and you got k is equal to, remember, the log base e is the natural log of negative h over 1,000 plus 1 all over negative n. And this would be your answer. Kind of weird, but probably why I should stop. Let's see what else we got there. Yeah, I'm going to let it go right there. So I hope this was helpful for you. Yeah.